Hey everyone, welcome back for another deep dive.
Ah,
So today, we're going to be looking at supersolids.
okay.
And specifically, we have a really interesting article that just came out in Nature
Oh, yeah.
about a supersolid that was created from light.
Wow. That's pretty mind-bending.
Yeah, so we're going to kind of unpack what that means. And
Okay.
we have an expert here with us today to help us unpack this really interesting discovery.
Yeah, I think supersolids in general are just a fascinating state of matter
Yeah.
because they embody this sort of like contradiction.
Okay.
The frictionless flow of a superfluid with the rigid structure of a solid.
So it's both a liquid and a solid at the same time.
Exactly. Like if you could imagine something that could flow through any crack or opening,
Wow.
but then at the same time it maintains this like fixed crystal-like arrangement of its particles.
That's pretty wild. So, I mean, I know that in the past, scientists have been able to create supersolids, but they've used ultra-cold atoms.
Yeah.
What's different about this new research?
Well, the key difference is really what they're using as the building block.
Okay.
So previously it was atoms, and now they've actually managed to create a supersolid out of photons.
Photons. So that's light.
Exactly.
Yeah, it's the stuff coming from my lamp right now.
Yeah, exactly the same stuff. So it's pretty remarkable because, we usually think of light as waves.
Right.
But this research shows that under certain conditions, light can actually exhibit, the properties of a solid.
So help me picture this. Like, what does a supersolid made of light, what does it even look like?
It's a great question because it is really hard to visualize.
Yeah.
Imagine for a second like a laser beam.
Okay, pure light.
Right, pure light.
Yeah.
Now imagine that laser beam somehow maintaining a very specific repeating crystal-like structure.
Okay.
But at the same time, it's still flowing without any resistance.
Wow.
So it's almost like thinking about a river that always flows in a perfectly straight line.
Yeah.
And all of its molecules are locked in place, but they're moving forward.
That's crazy. So how did these researchers pull this off? Like how did they create a supersolid out of light? It can't just be as simple as shining a laser through a prism, right?
No. It's definitely way more complicated than that.
Yeah.
They achieved this using what's called a photonic crystal polariton condensate.
Okay, that's a mouthful. Let's unpack that.
Yeah, there's a lot in there.
Yeah.
So first you've got the photonic crystal.
Okay.
And that acts as a very specifically designed maze for light.
Okay. So you're essentially controlling the way the light can move.
Exactly. You're really controlling the movement of the light very precisely.
Okay.
And then within this photonic crystal, they create what's called a condensate
Okay.
of polaritons. Now, a polariton is a quasi-particle,
Okay.
which basically means it's kind of a hybrid entity that combines properties of both light and matter.
So it's not quite light and it's not quite matter, but it's somewhere in between.
Yeah, it's this really strange in-between state. And then a condensate is a state where a huge number of these polaritons
Okay.
all start behaving collectively, like almost as a single entity.
Yeah.
And they're all governed by the same quantum rules.
So by very specifically controlling the environment within this photonic crystal, they were able to kind of coax these polaritons
Yeah.
into behaving like a supersolid.
Exactly. And it really is remarkable because this is something that we didn't even know was possible
Wow.
until, relatively recently. So who are these brilliant minds behind all of this?
Yeah, who's the team that did this?
Well, the research was spearheaded by a team led by Tripojorgos.
Trichogorgos, okay.
And what they've done is pretty remarkable. I mean, they haven't just created a new type of supersolid, but they've really opened up this whole new realm of physics.
Yeah, I mean, it really begs the question, like, what are the implications of this?
Right.
If we can control light in this way, like, what could we do with that?
Exactly. I mean, could this lead to new technologies that harness the properties of both light and solids? I mean, think about that.
Yeah, that's a great question. Let's think about that after a quick break. We'll be right back. Okay, so we're back, and we've been talking all about this incredible breakthrough, this supersolid made of light.
Yeah.
But like, what does it actually mean for us?
Right.
Where could this lead?
Well, I think, the potential applications are just huge.
Okay.
And we're really only just starting to scratch the surface of what we could do with this.
Okay.
Imagine, for instance, like optical computers.
Yeah.
That use light instead of electricity to process information.
Wow.
I mean, these devices could operate at speeds that we can only dream of today.
That sounds like something straight out of science fiction.
It does, doesn't it?
Yeah.
Or think about energy transfer.
Okay.
Right now we lose a ton of energy during transmission through power lines and things like that.
Right.
But what if we could create systems that could transfer energy with almost perfect efficiency using photonic supersolids?
Okay.
I mean, imagine the implications for something like solar power, for example.
So we could have like super efficient solar panels
Yeah.
that can capture and transfer energy with almost no loss.
Yeah, I mean, that's just one possibility.
That's incredible.
Yeah, there's so much potential in fields like telecommunications,
Okay.
quantum computing,
Wow.
even medical imaging.
Yeah.
I mean, the ability to manipulate light in this way just opens up this whole new world of possibilities.
Yeah. It's really amazing to think that this discovery, could change our world in ways that we can't even imagine right now.
Right.
But it also raises some pretty interesting questions, too.
Yeah.
We've been talking about these practical applications.
Yeah.
But what about the bigger picture? Like, what does this discovery actually tell us about the fundamental nature of the universe?
That's a great question, and it's one that physicists are really kind of wrestling with right now.
Okay.
Because this discovery really challenges our traditional understanding of like the boundaries between different states of matter.
Yeah.
If light, which we normally think of as a wave, can exhibit the properties of a solid wave, what does that mean for our definition of solidity itself?
Right. It's like all of our neat little categories are starting to break down.
Yeah, exactly.
And it reveals this much more complex and nuanced reality.
Exactly. And, it forces us to confront this idea that our understanding of the universe is constantly evolving.
Right.
There's still so much that we don't know.
Yeah.
So many mysteries left to uncover.
Absolutely.
And, that sense of mystery of the unknown, that's what makes science so exciting.
Absolutely. It's like every new discovery opens another door, and it just leads to more questions and more possibilities.
Yeah.
And who knows what incredible breakthroughs are just waiting around the corner.
That's right.
Speaking of breakthroughs, I'm curious to learn a little bit more about the research team themselves.
Okay.
What can you tell us about Trepogorgos and their colleagues?
Yeah.
Like, what kind of challenges did they face in making this groundbreaking discovery? It's amazing to hear about all the work that went into making this discovery.
Yeah, it's really inspiring to see that level of dedication.
For sure. So where do we go from here? Like, what are the next steps? What are the big questions that scientists are now trying to answer?
Well, one of the big ones is about stability.
Okay.
Can these photonic supersolids exist at higher temperatures?
Oh.
How long can they last?
Okay.
Another area of exploration is control.
Oh, okay.
Like, can we actually manipulate the properties of these supersolids?
So, like, could we tune their structure or their flow to suit specific applications?
Exactly. And that's where things get really exciting, because if we can control these properties, we could potentially use them for all sorts of amazing things.
It sounds like there's still a lot of puzzles to solve.
Oh, absolutely. But that's part of the beauty of science, isn't it?
Yeah. I mean, it's a constant process of exploration.
Exactly. We're always pushing the boundaries of what we know.
And I think this discovery also really highlights the importance of collaboration.
Oh, for sure.
This photonic supersolid wouldn't have been possible without experts from all these different fields. Material science, optics, condensed matter, physics.
It's a great example of how different disciplines can come together to achieve something truly groundbreaking.
Absolutely. So to wrap things up, we've gone from the basics of supersolids all the way to this amazing discovery.
Yeah, it's been quite a journey.
It has. What is the one big takeaway that you want our listeners to remember from today?
Well, I think the most important thing is to remember that we live in a universe that's full of wonder and mystery.
For sure.
There's still so much out there that we don't know, and each new discovery, like this photonic supersolid, opens up new avenues for exploration.
Yeah, it's exciting.
So I guess my message would be just to keep asking questions, keep exploring, and never lose that sense of curiosity.
Well said. I couldn't agree more.
Who knows what incredible secrets the universe still holds waiting for us to uncover them.
Exactly. Well, thank you so much for joining us on this deep dive into the world of supersolids.
It's been my pleasure.
Yeah. It's been a fascinating conversation, and it's a topic that I'm sure will continue to surprise us for many years to come. Until next time, keep those minds curious and stay tuned for more deep dives.